Assalamu alaikum wa rahmatullahi wa barakatuhu. Today our lecture number 13. So in this lecture we will study the next topic, which is 2.4 reliability analysis. So reliability analysis means to find the success probability of a complicated process with components in series and parallel. So sometimes we have some complicated processes in which we have the components which are connected in series or in parallel. So in series components, what we can see is that if we have let's say means हमारे पास जो components हैं वो सीरीज़ में है, मीन्स 1 by 1 एक कनेक्टर फिर उससे आगे दूसरा फिर उससे आगे तीसरा, या पैरेलल में है, ठीक है. सो उससे हमारे पास रिडंडेंसी बढ़ जाती है किसी भी प्रोसेस में, ताकि हम उसको उसके जो सक्सेस की प्रोबेबिलिटी है वो इंक्रीज़ कर सकें. या कुछ ऐसे क्रिटिकल हमारे पास ऑपरेशंस होते हैं जिसमें हम नहीं चाहते कि हमारा जो सिस्टम है वो किसी भी तरीके से कोलैप्स हो. सो अगर हमारे पास कंपोनेंट्स हैं सीरीज़ में, components in series. So components in series में हमारे पास अगर components हैं इस तरीके से W1, W2, W3 and so on, जितने भी लगे हुए हमारे पास. So अगर सपोज़ हम हर एक की प्रोबेबिलिटी ऑफ सक्सेस P है, तो प्रोबेबिलिटी के ये जो सिस्टम है दैट विल वर्क विद द प्रोबेबिलिटी विल बी P into P which is P cube. If it is n components, for n components simply it will be P into P into P into P. So there are n components, so that will be Pn. But if sometimes it's possible that the probability of these components is different, each component has different probability, say W1, W2, W3. So say its probability is P1, P2, P3. So there is nothing to worry about. The probability of success of this series components will be simply P1 into P2 into P3. Similarly for n components, probability of success will be P1 into P2 into P3 into Pn. So that will be the probability of n components in series with different probabilities. Now components in parallel. So in parallel components, say we have W1, W2, W3. So in this kind of setup, we can see that even if one of the component is working, our signal will pass through, or our component will work. So how we can find out the probability of success here? So first we have to look at the probability that how it will fail, because that's easy to find. That probability that this component will not work, that will be obviously W's complement. So that will be simply the probability of W1 complement, W2 complement, W3 complement, and if all have the same probabilities, so it will be 1 minus p power n, because p is probability of success. Probability success, so obviously 1 minus p is probability of failure. So for n components, it will be simply probability of W1 complement into probability of Wn complement, which will be simply 1 minus p power, sorry, here it is 3, it would be n. Similarly, if these probabilities are different, so it would be the same procedure, simply for different probabilities of each component. Different probabilities of each component. So that would be simply probability of WC, which is equal to 1 probability of W1C, W2C, and I am just writing for W and C. So it will be simply 1 minus P1, 1 minus P2, 1 minus Pn. So what will be the probability of success in this then? So probability of W will be simply 1 minus probability of WC. So that will be simply, if we just take that use of theorem, that property that we have seen, the consequence of axioms, so that we can use here. So probability of A complement plus probability of probability of A plus probability of A complement is 1. So we can find out this probability. Okay. Now let's see this example. So I will copy the example from the book here. So it says that an operation consists of two redundant parts. The first part has two components in series, W1 and W2, and the second part has two components in series, W3 and W4. All components succeed with probability P, which is 0.9. So first we have to draw a diagram of the operation and calculate the probability that the operation succeeds. So it says that we have two branches. In each branch we have two components in series, W2, and in another branch we have W3, W4. So the first step would be to solve them in series. So if we solve them in series, so say we call it as 5 and say 6. Now again we can solve them to find single component W7. Remember that we are not physically reducing them, we are just finding the probabilities, what is the probability of success of this process. So for the components in series, so this is PW5, so we say that PW5 will be simply the sum of these, the product of these two probabilities which are in series, PW1, W2, and which is they have the same probability P square, which is 0.9 square, and it is 0.8. So similarly, probability of 6, which is probability of W3, W4, again it is P square, so that is 0.9 square, which is 0.81. Now we have to solve these 5 and 6, which are now in parallel with each other. So we will get PW7. So we have to find first its complement. So that will be probability of W5 complement, W6 complement, and that will be 1 minus, say this is P5, 1 minus P6. So that is 1 minus 0.81, 1 minus 0.81. So that is 0.19 into 0.19. So this is 0.0361. Now we have to find the probability of success. So that is probability of W7. So which is 1 minus P W7 complement. So it is 1 minus 0.0361. So it comes out to be 0.964. So the success of this system is 96% with all these redundant components in part, because we need redundancy just like in the spaceship. So we have a lot of redundant computers which are connected in parallel, so that if at least if one computer is working, one CPU is working, so our shuttle can be operated properly. So otherwise, if we have only installed one computer in such a critical system, so it would not be possible. If one of the computer fails, then whole system is will be collapsed. So obviously that is not required. So we put a lot of redundant computers there. सो रिडेंडेंसी का मतलब होता है फालतू चीज़ डाल देना। तो हम फालतू चीज़ें डाल देते हैं ताकि हमारे सिस्टम में जो उसकी रिलायबिलिटी है वो बढ़ सके, क्योंकि जो सीरीज़ में कंपोनेंट्स हैं उनमें अगर एक भी कंपोनेंट फेल हो गया तो ऑब्वियसली वो कंपोनेंट पूरे का पूरी लाइन काम नहीं करेगी। जैसे इंडस्ट्रीज़ में असम्बली लाइन होती हैं, असम्बली लाइन प्रोडक्शन होती है, तो असम्बली लाइन प्रोडक्शन में एक जगह पे भी एरर आ जाए तो पीछे से जो कंपोनेंट्स हैं वो आगे नहीं चल सकते। सो हमें पूरी प्रोडक्शन को स्टॉप करना पड़ता है। आई होप यू हैव अंडरस्टूड। दिस इज़ द एंड ऑफ दिस चैप्टर। अगेन द लास्ट पार्ट इज़ जस्ट मैटलैब एक्सरसाइजेस। सो आई विल सजेस्ट कि आप मैटलैब एक्सरसाइज करें थोड़ी सी, ठीक, और एटलीस्ट इसकी जो मैटलैब की एग्जांपल्स हैं वो लाजमी करें, और एक्सरसाइज के जो क्वेश्चंस हैं वो लाजमी करें। एटलीस्ट जो सर्कल और स्टार मींस इजी और मॉडरेट डिफ़िकल्टी लेवल के साथ हैं वो लाजमी करें, और जो इंटरेस्टेड है वो आगे वाले क्वेश्चन भी कर सकते हैं होपफुली। और स्टे ब्लेस्ड। अस्सलामु अलैकुम व रहमतुल्लाहि व बरकातहू।